The following is the details and objectives of this course. Please read it carefully, and start the course. Gasoline engine is light with high durability. Various technologies for improving performance and fuel efficiency as well as noise and vibration reduction have been applied. Major technologies applied in gasoline engine can be summarized in the areas of weight reduction, size reduction, improved durability, increased output, reduced noise, and reduced vibration. Let's take a look at each one of them. First, engine weight reduction is achieved by changing the material for major components. In place of cast iron, aluminum material is used for cylinder block. Exhaust manifold is also changed from cast iron to stainless steel. In addition, intake manifold as well as other components are also changed from aluminum to plastic for reduced weight. In addition to material change, weight reduction of engine is also achieved through reduction in size. In the past, accessories, such as air compressor or alternator used multiple belts. But now, serpentine one-belt type, which drives the accessories with a single belt, is applied for more compact engine. Torque converter and auto. With the improved engine performance, improving its durability to withstand the increased power is recognized as an important issue. As a result, the previously applied timing belt for crankshaft and camshaft is changed to semi-permanent timing chain for improved durability. In addition, various new In the past, cylinder head used only one camshaft to drive the intake and exhaust valves. Since only one camshaft is used, maximum number of valves per cylinder was limited to 2 or 3. This is known as single overhead camshaft engine type engine. Dual overhead camshaft engine is the engine technology developed to overcome such limit. There are 2 camshafts per cylinder head in a Doak engine. This type allowed more than 4 valves per cylinder, which maximized engine charging efficiency and improved performance. Next is the technology for improving fuel efficiency. Metallic components in engine causes power loss due to friction. Reducing such friction improves engine rotation which also leads to improved fuel efficiency. As a result, special coating is applied to various mechanical parts, and low-tension piston ring, low-tension valve spring are applied for reduced friction. Next is the technology for improving fuel efficiency. Metallic components in engine causes power loss due to friction. Reducing such friction improves engine rotation, which also leads to improved fuel efficiency. As a result, special coating is applied to various mechanical parts, and low-tension piston ring, low-tension valve spring are applied for reduced friction. Next is the technology for improving fuel efficiency. Metallic components in engine causes power loss due to friction. Reducing such friction improves engine rotation, which also leads to improved fuel efficiency. As a result, special coating is applied to various mechanical parts, and low-tension piston ring, low-tension valve spring are applied for reduced friction. Next is the technology for improving fuel efficiency. Metallic components in engine causes power loss due to friction. Reducing such friction improves engine rotation, which also leads to improved fuel efficiency. As a result, special coating is applied to various mechanical parts, and low-tension piston ring, low-tension valve spring are applied for reduced friction. Next is the technology for improving fuel efficiency. Metallic components in engine cause Next is the technology for reducing noise and vibration. Because the consumers today demand more quiet engine, this is one of highly important technologies. Balance shaft module is applied to absorb the vibration generated during the combustion process. And to improve structural integrity with automatic transaxle, ladder frame type is applied, which also reduced vibration and improved durability. In addition, noise absorber is applied on key parts to prevent noise from traveling into the interior. Next is the technology for reducing noise and vibration. Because the consumers today demand more quiet engine, this is one of highly important technologies. Balance shaft module is applied to absorb the vibration generated during the combustion process. And to improve structural integrity with automatic transaxle, ladder frame type is applied, which also reduced vibration and improved durability. In addition, noise absorber is applied on key parts to prevent noise from traveling into the interior. Among the major systems in an engine, we will first examine the ignition system. Ignition system applies spark on the compressed air-fuel mixture. It is mainly composed of ignition coil and spark plug. Ignition coil generates high-voltage ignition energy, and the spark plug converts the energy into a spark in the combustion chamber and ignites the fuel. When we review the advancement in ignition system technology, the ignition coil first started as distributor type, which was mechanically operated. With more electronic control applied in the engine, the distributor type is replaced with the DLI type. DLI uses one ignition coil to activate two spark plugs, to improve durability and reliability. Recently, DIS type has been applied. This is the ignition system in which one coil is applied for one spark plug, for independent control of the spark plug. This achieved faster response and improved durability. Ignition plug is consumable part, in which the electrode part of the plug is worn out by the electrical spark discharge. So technology development has been concentrated on durability. As a result, the previously used nickel spark plug has been replaced with more durable platinum spark plug. But recently, most of the engines are equipped with iridium spark plug, which has higher durability than platinum. Iridium spark plug is highly durable with exchange interval of about 160,000 kilometers, which achieved cost reduction and high customer satisfaction. Cooling system has a function that prevents engine from overheating by cooling various parts of the engine. It also maintains optimum temperature for engine operation. Recent engines use inlet control type, in which the water temperature controller, thermostat, is installed at the engine inlet. It improves warm-up time in cold weather, and reduces coolant temperature deviation when thermostat is active. In addition, separate cooling type, in which coolant is directed into cylinder head section, which has higher temperature than the cylinder block, is applied for optimum engine temperature control. We will continue on to the characteristics of the lubrication system. In general, gasoline vehicle needs engine oil and oil filter changed at about every 15,000 kilometers. But recently, there are engines with environmentally friendly ECO filter, which minimized waste by exchanging only the internal cartridge inside the oiled filter. When the engine RPM increases, the oil pump RPM is also increased. So if oil pressure is excessively high, then pump power loss results. Variable oil pump is the lubrication system developed to solve such problem. Variable oil pump controls the oil discharge pressure to prevent formation of excessive oil pressure. This reduces oil pump power load and improves fuel efficiency. One of the most significant changes on intake exhaust system is the change in intake and exhaust position. In contrast to the previous positions, the intake manifold is placed at the front section of the vehicle. In other words, cooling effect is improved by taking in natural air by positioning the intake manifold in the front. And with the intake air noise positioned away from the interior, the noise inflow into the interior is suppressed. This repositioning also allowed simplified exhaust manifold structure. Gasoline engine is equipped with a throttle valve, which controls the intake air volume based on driver's acceleration intention. Structural change corresponding to the need for precision control, for increased application of electrical control in a vehicle is applied. Previous throttle valve was mechanical structure that opened and closed by a cable in the amount corresponding to the acceleration pedal pressure applied by the driver. But with increased application of electrical control on the engine ECU receives driver's acceleration intention, and then activates the electric motor installed on the throttle valve. The electrically controlled throttle valve system allows higher precision intake airflow control. This achieved performance enhancement, while reducing emission gas. Intake manifold is the path for air flowing into the combustion chamber through the throttle valve. The length on the intake manifold is changed with variable intake system that directs optimum intake air corresponding to the engine speed. Variable intake system directs optimum intake air corresponding to the engine RPM for improved charging effect. Most recent engines are equipped with CVVT system, which variably controls the valve opening-closing timing based on the engine load condition. In addition, application of CVVL system, which directly changes the air intake in the combustion chamber, by controlling the valve opening lift is increasing. The latest trend in engine design is downsizing to produce high output, with low displacement in response to environmental problems. In case of diesel engine, turbocharger has been applied since past to achieve engine downsizing. But it was difficult to apply turbocharger in gasoline engine due to knocking issue. But with significant advancement in engine technology, application of turbocharger in gasoline engine has been increasing. This allowed engine downsizing and achieve high output with low displacement. Gasoline turbocharger is driven by the exhaust energy, which was previously lost. It has benefit of achieving synergy effect of increasing power output, while recycling the lost energy. As a result, gasoline turbocharger engine achieve powerful output, with low displacement engine, through improved charging efficiency. Another system is the idle stop and go system, which prevents unnecessary engine idle when a vehicle comes to a stop. ISG is a system that automatically stops the engine when a vehicle comes to a stop, and automatically starts the engine when the vehicle starts to move again. This is environmentally friendly technology that reduces fuel consumption, as well as emission gas. Some European countries are implementing various government incentives, including tax reduction, and this trend is gradually expanding throughout the world. Fuel economy varies depending on a driver's driving habit, even in a same vehicle. ECO driving is the feature that displays the current fuel economy status in real time. It allows the driver to check the vehicle's fuel economy in real time through change in ECOM color in the cluster. The system guides the driver for more economical driving habit. Recently, more advanced active ecosystem is being applied in many vehicles. Unlike the previous eco driving system, the active ecosystem is a smart feature in which the vehicle engages in high fuel efficiency driving by a selection of a switch instead of performance-oriented driving. It's an environmentally friendly feature that gets the vehicle to control fuel injection, auto transmission gear shift pattern, and air compressor with priority in fuel-efficient driving. Gasoline engine generates evaporative gas as the temperature increases due to the characteristics of the fuel. This evaporative gas is composed of hydrocarbon, which is harmful gas that forms smog in the atmosphere. As a result, the amount of hydrocarbon released through emission gas is also strictly regulated. In addition, gasoline gas discharge must also be suppressed to conserve fuel. Catalyst is a substance that accelerates chemical reaction on other substance, while it remains the same, under a condition with certain amount of pressure and oxygen. In an automobile, it converts harmful emission gas substance to harmless substance, through oxidation-deoxidization process. In other words, it oxidizes CO and HC to convert to CO2 and H2O, and deoxidizes NOx to convert to nitrogen and oxygen. This newly formed oxygen then reacts with CO to form CO2. Click the tip button to view more detailed information on the category of the catalytic converter based on its installed location. Please review the lessons you've learned in this session through simple quiz. Now, let's wrap up what we've learned today.